So can everyone hear me? People in the back, can you hear me? Okay, so I'm Lars Holman. I will talk about what is the vision for the application, where we're heading, what are the new features, and how should it look like in the future. I did this presentation on replication fix and tips together with Mats Lindholm before, and the slides are available here if you want to follow them. So I will go through three different things: the vision, where are we heading, and this is how I see it, and it's up for discussion, and it can be different people from different opinions about what is most important. I will discuss what features have been developed. I will briefly mention 5.0, but then I focus on 5.1 and 6.0 and beyond. And then I was thinking about what we call the last one, but it's like we have all of these features which are being developed and we're designing it, and then we are picking things which will belong to the releases in the future. So what is the vision? I think we need to take replication in the future. We need to do 5 things. We need to make it faster. We need to make it more flexible. It should be possible to fail over in more ways than it possible today. We should have an update everywhere, so that we can take any kind of SQL server into update, and then things get replicated and become resolved somehow. And we want to move it into a pluggable architecture. So there's different projects going on where people do different kind of variations of the replication and want to make that easier so that we can plug in other components which will take the binary log and do something. So to get it faster, it has to be parallel execution. We need to remove some limitations, something like that. For the failover, we want it to be possible to do it automatically, so we would provide different information, so it's easier to do failovers automatically. And update everywhere. As I see it, there is 3 different solutions to the update everywhere problem, or the multi-master, which people often talk about. And the first one is to have synchronous replication. And we're not really going there with replication now. We have the MySQL cluster, which has synchronous replication inside. But for the asynchronous replication, we are more into the second solution, which is conflict detection and conflict resolution. So we replicate all the things after they have been committed, but then we resolve it somehow. And this often has to be something which the database administrators have to decide what is the best resolution method for their data. It could be that the last one wins, or everything which comes from this server is more important, or something like this. So fast replication. We want to have a multi-channel replication for performance. So instead of just going from one master to a slave, and it's one thread going to one thread, we want to have multiple threads doing this. And we also, for cluster, we want to have multiple slaves doing this. So the idea is to better utilize the hardware. We want to have better caching. We want the epochs to be smaller so we have low latency and replicate. So if you do some change on the master, it should go faster over to the slave. Slave batching is that when the transaction comes to the slave, we want to send more information to the storage engine so that the storage engine will execute these things. So we don't wait. This is especially important for cluster because we can send more information down to the storage engine so it can execute it in that way. And we're considering making the node into lead. So currently, the transaction is stored sequentially in the log in the serialization order. But in the future, we might mix this so that you have two transactions stored on the same time. And it means that you can, when you start transaction on the master and it's being executed, you can start writing it right away. But we need to keep track of which transaction is which statement or which operation belongs to which transaction. Some questions so far? Yep.
What versions are you talking about in the store?
This is the big picture. So this is where we're heading. So I will soon go into more. First, I will talk about the overall vision where we're heading, and then I will go into more directions where the different features are, the steps which we are making to move in this direction. There was some more questions also. Okay. So we want the replication to be more flexible. We want it to be possible to use any kind of replication topology. It should be possible to filter in more ways. And it should also be possible to filter before it comes to the slave. We want so that you can have filtering on two different servers. It should be more possibilities to express, for instance, a regular expression that you want to filter on databases which look like this, or now you can filter on the slave with using wildcards and have some kind of regular expressions, but this can be more advanced in this sense. We want to filter on data, and we want to have dynamic options. So when we change that things, we are more moving into that you type SQL statements to change it instead of having options into the MySQL file. We want to make it easier to failover. And we want to have multi-channel replication for redundancy. So in cluster, you put two channels between the two clusters, and you have one active, and if that fails, you move to the other one. Filtering on more than one server. This is if you have server replication and you remove one server, we need to eliminate events which was produced by this server which was removed. So this is again moving into more flexible topologies on how to failover in this topology. And also to do this, we need log position relative to originating server. So this topology where slaves and masters replicate to each other. We see the masters as streams where things are produced, and we need to have more, the slave needs to know more the position it is in related to all of these originating servers. Update everywhere towards the multi-master. We're working on the conflict detection and conflict resolution. So conflict detection is just that it has discovered that the data is changing. So in Firewall we introduced the row-based replication. And in row-based replication we can send not only the value that should be on the slave, but also what it has been. So we check what it has been and we compare it to what the slave has. And if it's the same, or rather if it's different, we see that someone has gone into the slave and changed something in between. So that way we can detect conflict. And when these conflicts happen, when something has been changed on both servers at the same time, then we want to resolve this conflict and using stored procedure mechanism to say that, well, this row should win or this row should win. And multi-source is needed by many topologies. And multi-source is when you have two masters going into one slave. Then we want the architecture to be pliable. So if we look at what we have done in MySQL, in 4.0 we introduced this extra IO thread. And from 4.0 to 5.0 it's kind of the same architecture. But there is one thread reading from the bin log. We execute something, we put it into the bin log. And in these versions we have statements which we put into the bin log. The down thread is reading it, it's sending it over to the slave, and the IO thread is receiving it. It puts it into this relay bin log, which is kind of a buffer. And then the SQL thread reads it up and it applies it. And then there's 2 caches about these log files, so that if you are within the cache, you don't have to go to this, you can read it from. In 5.1, we introduced row-based replication. And in this architecture, it's not only so that the statements, as they are given from the user, are everything to the bin log, or log to the bin log. It's also the case that that just before you go to the storage engines, like MyISAMD and DB, just before that, you have the rows of data which should go into the storage engine. And in 5.1, we can catch these rows and we can log them. So in 5.1, we have both the statement base, where the statements are replicated, and we also have the row base where the data is replicated. Questions? Yes?
So is there any chance we'll have some way of getting human readable output for row-based replication of this? So I can see which row has changed?
Yes, that's one of the things which we are working on. It's currently in the MySQL bin program, you get human readable for the statements, but for the rows, for the row lengths, it's very hard to see what they contain, and we're working on fixing that so that we have better comments and better printouts for the page. More questions? How many have used 5.1 up to the hand? What does that mean? How many have used 5.0? So in 5.1, we also have an injector interface, and this is used for cluster replication. So you go from one cluster to another using this asynchronous replication, and to put the story or the reason for this to do it short, the idea is that in cluster, the serialization order, the way things are being executed, the order they are being executed, is determined inside the cluster. And if you have multiple MySQL servers connected to one cluster, then we need to know this order from inside the cluster. So we pick it up and we insert it into the binary log. So in 5.1, there's actually 3 ways that logging can happen. You can log the statements. You can log rows just before they go into the storage engine, or you can get them through the injector from the cluster. So it's sent from the cluster up. It's a way to inject replication log into the binary log. Any questions? More questions? Okay. So in the future, what we will do is that we will use the same code as we have now, more or less, but we will split it up and put in APIs between the different components. So we will make it more pluggable. So on the master, there will be a logging kernel. Often when there is some kind of functionality like this, it's the same for online backend. There's a kernel component which in this case, it will decide should it be row-based logging or should it be statement, and sometimes it has to switch between these formats when statements are better for replicating one. So this component is very closely connected to the MySQL server. And this is the kernel. Then there's a log storage, which handles writing this to disk. And in the future, it could be that it doesn't write to disk, it writes it into a table. If you write it into a table, then you can do other things. You can use indexing mechanisms to find things in the log, and you can do different things on this. So the storage component will be a separate component as well, so that you can exchange it. And then we have a transmitter of the information, which just asks the storage, log storage for entries, and then it's transmitted into the receiver part. And the receiver part gives it to a buffering component, which stores on the relay bin log, and then it goes to the flyer and puts it up. So this is where we are. And in this, the things we get with this pluggable architecture is we get, you can have the kernel can be a little bit different. If someone wants to have, if some customer or user wants to have a certain kind of replication, or it should be faster in some senses, then we can do custom builds for that, or someone can go in and hack it themselves and do something. So how it's been logging. Also, the storage could be in bin log files, and it can be in system tables. The transmitter receiver could be, it could be a TCP, or it could be some other interconnect, and it can also be things so that it's not sent to other MySQL server, it's sent to something else, or it could be changed in some way. And the relay buffer, it's also, we can store it in files with system tables, and the applier can also do different tricks. And the applier, when we create multi-threaded appliers, which will execute things faster for certain kind of scenarios, then what can change this. So what have we actually done to move in this direction? Well, in 5.0, we have some other increment variables for bidirectional replication. So in MySQL, you can always set up two servers which replicate to each other, but you need to be aware that the data is disjoint, that you only update the odd rows here and the even rows here, or do some kind of thing like that. Because if you don't do it and update the same row at the same time, this update will go over here, and this update will go over here, and they will actually have different data. So one trick to handle that is that you always update different things on the two servers. And in 5.0 we introduced some variables so that if you use auto-increment columns, you can do this again. And then there were some variables which were being replicated, and time zones, and we introduced replication for store procedures, triggers, and views. And we introduced this text dump so that you can view what is in the bin log, most important debugging, and see more clearly what's in the bin log. So this is, I showed this on the tips and tricks session as well, how you can make one server generate auto-increment number like 1, 3, 5, and the other one will generate 2, 4, 6. So the data will be disjoint, and then you can replicate each other. So you can have a multi-method. And what we use is we use two variables. We use where should I start this chain of numbers, this sequence of numbers, and how much should I increment it. So this will be 1 for this one, 2 for this one, and it will be 2 for both, all the steps. Steps at a time. Questions so far? Very silent audience today. So 5.1 has more things. We have the row-based logging and row-based replication. And one can actually switch between these formats dynamically. So So you can execute some statements, and they will be executed in, they will be logged as the statements, and then you can switch into row format, and then it will be logged as data instead, and then you can switch back. Sometimes it might be more effective to do it by row, and sometimes it's more efficient to do it by statement. We also made it possible to replicate between clusters, and then what is sent over is not transactions, but it's rather epochs, which is a sequence of transactions. So we will treat multiple transactions as a huge transaction. So for the replication, in the cluster there is still the transactions, but when it comes to replication, it will handle it as a big transaction actually containing multiple small ones. We introduced this incident events. So in the binary log, we send, if something happens inside the cluster, actually in the MySQL server, which the cluster belongs to, so that it cannot replicate correctly. And this is restarted and there's a gap of the replication stream. So in some cases where things happen in cluster, then we will send information over to the slave so that the slave can switch to a different channel. So between the clusters we have multiple channels. One is active, and if something happens to this active channel, you can switch over to another channel. So you have automatic, and you can do that automatically. You have to script it, but it's not that hard to script it. We have this bin log statement for robot-based log events, so that you can still use the MySQL bin log program on the binary log, and you get SQL statements, and then there's one new kind of SQL statement, which is a bin log, and then there's a basic SQL encoding of the data. There is this internal injector support, and that's used for the cluster to put things into the log. Yes?
Is there any chance that we can have the option of saving the original SQL statement as a comment event when we use row-based replication? Because some of us really like to refer to that when there's problems with the system, to see the original row change SQL statements. It's
a very good request. Yes, it has been discussed before. We haven't really thought of implementing that right now, but it is something that we should do. Yes.
Would you still be able to utilize the bin logs and row-based replication model? Apply the bin logs to the private?
You can still apply the bin log using the MySQL bin log program and pipe in. Yes, we can do that. Because when you use the MySQL bin log program, you get a kind of SQL statement, which is very hard to read for humans, but you can put it into the MySQL client so that it will execute it into the master. Yes?
Yeah, is there, you might have covered this already, but is there a practical way on a sort of relative table in the master to figure out when it's the equivalent tables? So like statement of replication, so you implement statement of replication.
Okay, so you have one way, and that's knowing the number of seconds the slave is by the master. But what you're aiming for, I guess, is something which is you do not say that this has been committed unless it has already been replicated to the.
At least one side.
Yeah, it's a thing which we have been discussing a lot, and it's on this wish list, or whatever we should call it, the multiple things which are being developed. But it depends a little bit on what are people screaming for the most, and then we pick those things into again. But this is one of the things which are on this. And also is to write the statement names into the bin log. In file 1, you also have it's a storage independent logging format, so you can You can always use different storage engines between when you replicate. This has been working before as well. That you can replicate from MyISAM into InnoDB or something like this. But now we actually made the format independent, so it will be more extendable in the future. We also have replication of events. So the events are timed events, and we couldn't really know. We cannot execute events as they are because there is a time, and we don't really know, did this fire exactly after this statement or before the statement. So in row-based replication, we replicate the effects of the events, and and at the creation time, when we create events, we replicate over the event to the slave, but we put it as disabled. So for events, we replicate over the effects. And when we create events, we just replicate it over. So the slave still has the information that there is an event, but it's marked as slave side disabled. So if the master is failing, then you can enable these events, and then you will get a new master which has both events and everything else that you have. But while the replication is going on, the events will be marked on the slave as disabled. We have engine level logging capability control, which means that some engines can only use statement-based replication. For instance, federated and black hole, when you use black hole in the middle of chain. So some of them can only use a statement, and some can only use row. So cluster will only use row. And in DB will only use row in some circumstances as well. And the engine can control, this is something we're calling right now, the last part of this. So the engine can control and say, I can do this kind of logging and I cannot do this kind of logging, and then it will, the server will pick this automatically. We have refactored code for group transactions. So this is mainly an internal thing, but it would make it easier to move into the vision something before. So this refactoring is mostly code changes, so it would be easy to do this kind of thing. We'll separate error reporting for the IO and SQL threads. The threads are two different objects, so they can have different error conditions, and this is now reported separately. If we create the UDF, then this is being replicated. And the MyCNF options are being deprecated, and change master is the one who uses that. And this, one of the main reasons for this is the multi-source, where you would be able to on the slave to say which master, different masters which are connected to this layer will have different properties. So instead of using a very large option file, you would use change master command, so you can also do this dynamically.
Would it say that? Would the slave save that information during the restart? Or the master information that's connected?
It will lose that information. No, it saves it in the master info file. So you still have it. So the information, when you do change master, you put it into the master info file. And if you do restart, it will read it from the master info file. The only thing which is changing is that you don't no longer specified in the MySNF file. What was this? Yes?
Yes, currently, if you don't want certain statements to go into the bin log, you can set that with SQL log bin or something like that. Can you still do that with row-based replication?
Yes, you can do that still with row-based replication. It currently doesn't really work for microcluster, but this is being fixed right now. So if you don't use microcluster, then it will. performances. So some of the advantages of role-based application, and I think this is a important list because all the time I find new reasons why role-based application is the way to go. But some of these are, if you have non-deterministic statements, which for instance use UID or something like this, then if you replicate the data, if you use statement-based replication, you have to have exactly the same context on the master and the slave. So we need to ship a lot of information about variables, and for random numbers we need to ship the seed over to the slave. So exactly the same random number will be generated on the slave. But with row-based, we only ship over the data, so the random number has already been generated. So we do not re-execute some statement on the slave, we ship over the information as well. And it also makes it possible to replicate between MySQL clusters when you have multiple MySQL clusters connected to MySQL servers connected to one cluster. If you only have one server, then you can still use statement-based. But row-based is not. And there's a lot of tricks possible. We were showing some on this replication tricks session. And still, statement-based replication is still, we have had it for a very long time, so it works. We know exactly how it works and people use it and people are happy with it. Sometimes it produces a smaller log file because if you execute the statement, set x equal to x plus 1 or something, and it will generate a lot of new data, a lot of changes. And if you use row-based replication, you send over all of these rows, but in the statement-based replication, you only send over the statement. So sometimes the log is smaller. And the binary log can be used for auditing, and as you were commenting, something which we should add is that you can put the SQL statement variables. So you can also use what's currently written. Row-based replication, it has 4 new events. It has the table map event, which says that an identifier maps to a table name or a table definition. And that's just so you get a number, so in the rest of the log, you don't have to refer to the whole table name, you can just refer to this number. This is just information. And then you can do a sort of insert, or you can do an update, or you can do a delete of information. And if you do an update, we also send this before image. So the after image is the row as it should look after it has been applied on the slave. And the before image was how did it look on the master before it did something. So when we get the before image over, we see what did the master think this row was before it did something. And we can compare that to the information the slave has and see if the slave has done some changes of this information in between, and that will be conflict. And then there's various optimizations one can do in this format. You can pick out different columns to send and only send the primary key in the before image. It's a quite flexible format, and there are different requirements on. Sometimes it should be, we only want to send very little of the information, so we only want to send some columns, and that's how it works in cluster right now. And sometimes we want to send the whole before image so that we can do this conflict detection and resolution. And you can switch, as I was saying before, that you can switch between these formats dynamically. So you can just set global stable format to be row to be connected. So all the clients will replicate in row format from this point on. And you can do that for the session also, so that only the connection you are at, only that connection will use row format. And there are different ways one can optimize replication. So you can use statement or mixed when many rows are being changed, so you only send the statement. And if you have a very complex SQL statement that doesn't actually update so many rows, you could send the rows instead. So you can check it. And this is just showing that you can have engines which have different capabilities. So it might be able to log with rows. So this is row logging capable. And if it's statement level capable, it will be yes in this column. And then depending on how you set the bill of format to be, and what is the capabilities of the engine, then you will have different, in some senses you get not loggable, but that's the weird ways when the engine doesn't really do what it's supposed to do. And then it will be logged in different formats. So the server can, depending on what kind of storage engine you use and how you set this bill of format, the server will decide how this will be replicated. And this looks more complicated than that. In many cases, you just say, I want row level logging and everything will be rows. So in File 1, we also have cluster replication. So you have inside the cluster you have synchronous replication, and between clusters you have asynchronous replication. So in this using cluster you have both synchronous and asynchronous. And this is my guess, which will be the 5 features after File 1. And it's that we will have checksums when we check the tables on the master and slave during replication and check that they are same, correct, that they are the same, so that when things are not the same, replication will tell you that something is wrong with this table or something. So it's extra information. Conflict detection, so that you can detect that if you update the same row in 2 different servers, you detect this and you can do measurements. You can have some program or you can do something about this conflict if you update the same row. And conflict resolution will be some simple version where you can just do some simple timestamps, so you always take the latest one, so the highest timestamp always. Multi-source is that when you replicate from multiple masters into one slave. And online backup, and it's used to initialize slave also. Online backup, when you do replication, you have to initialize slaves so that they have some starting point to start from. And online backup will provide this backup to start from. And we want to connect this to load data from master, which is a deprecated command. And this will be reintroduced so that you can execute it on a slave and it will send over the information somehow and you continue with the replication. Or that will be the software. Yes?
Introduce some feature to delay replication. Say I wanted a slave about 5 minutes delay.
Yes, that's also one of the things on this, which I call the wish list, or this bunch of features which are taken from to the next release, which pieces will be put in.
Likely.
What is it likely? I would say it's quite likely because it's not. It has been discussed for a while, and there's many people who want that. So, so these are some of the things which we have designed and which we are working on. And from all of these features, we pick the things which will be put into the next releases. So more advanced filtering options. For instance, you can filter by view, or the slave to be faster, and that's we're working on multiple ways to make the slave faster. Also, to have multiple partition bin logs so that on the master you store the information in multiple bin logs, and then when the slave connects, it can pick the bin log it wants to replicate from. Master list of slave positions is that it will make it easier to fail over. So the slave will know more about the originating server positions. So when you switch from one master to another master, it can read out the events it already has executed and pick the ones it should execute. Because in the topology, when you have servers replicated in some sense, in some graph, then the log from one server can be interleaved in some way. It can be some events, some transactions after each other. And if you move to the other one, if you fail over to the other one, it can be a different order. So having these positions would make it possible to switch over. Filter of tables in the bin log, so that you can do more filtering there. Master filtering is that currently you're filtering before you go into the bin log, and you're filtering on the slave before you apply it. And we want to have filtering after you read from the bin log and before you send it over. So the dump thread will do the filtering. And in that case, you will not send so much on the replication. Easy to find bin log positions on the new master. It's also related to this that you know more about the positions and you can fail over. Load balancing of clients when you connect. It's not really in the replication team, but you can connect to. You can see more about what the replication is doing. Table checks was this that the replication takes care of doing a checksum on the table on the master and the slave, and you compare it on the new replication. And print function for row-based events is not really printing the SQL statement, but printing the data of the row-based event. Compare slave with master during replication. It actually tells. It's a repetition of this thing that you have checksums which are comparing the information. Delayed replication, which was mentioned before here, which is the same as time delayed replication. System tables for mastering for relay log info. Since we will in the future have multiple masters, there will be much more information about how these are connected. So this will be put into system tables instead of on files. Replication heart beating. And this will be used both to check that the replication is going, and also it will give a better precision in the time behind master. You will know more accurately that this is correct. So, two things. You directly detect that the master is no longer there or there's something wrong with it. And the second thing is that the seconds behind master is calculated when you receive events. And if you don't receive events for the master because it's not doing anything, then the time behind the master can be, you cannot be as sure about that number. But if you send the heart beating, that will update the time for the body.
Does that have any impact on compilation changing master?
Wouldn't really matter so much because when you change from one master to another, you will change master command, and then you will set different requirements in the heartbeat. So it will be like you started it from new from this other master. So I don't see that should be any problem. Okay. Is it time up or? Okay. The way to replication, but we replicate it over to the slave. And this is not in the near future, but it's something which we are thinking about designing in this stage. Lower latency replication is also like efficiency thing. But stream bit log reader is when we put when we make it more pluggable, then it can also be possible to read this in a different way by different kind of components which MySQL will provide and which others can provide as well. Yeah, pluggable replication in general, that it can be possible to replicate different ways. So, questions? This is it. There is a world service session tonight, which is more an open discussion and bring in questions or whatever you want. And there is a talk tomorrow about online backup and also about further